7269. Swapping wings from one brand or type of powered parachute to another is A. Permissible as long as the basic shape of the parachutes are similar. B. Dangerous since every wing is designed for a specific aircraft. C. Permissible if the overall area of the parachutes is the same. The correct answer is B. Swapping wings from one brand or type of powered parachute to another is dangerous since every wing is designed for a specific aircraft. Powered parachute wings are carefully designed and engineered to match the specific aircraft they are intended for. The design of the wing takes into account various factors such as the weight and balance characteristics of the aircraft, the performance requirements, and the handling characteristics. Each wing is optimized to work in conjunction with the specific aircraft it is designed for. Swapping wings between different brands or types of powered parachutes can introduce significant risks and safety concerns. Wings are not interchangeable or universally compatible across different aircraft. The wings are designed with specific airfoil shapes, dimensions, line configurations, and performance characteristics that are tailored to the aircraft they are intended for. Using a wing that is not specifically designed and approved for a particular aircraft can result in unpredictable flight behavior, loss of control, and compromised safety. The mismatched wing may have different flight characteristics, aerodynamic behaviors, and structural capabilities that are not compatible with the intended aircraft. Therefore, it is not permissible to swap wings from one brand or type of powered parachute to another, as it is dangerous and can lead to unsafe flight conditions. 7270. Degradation of the parachute's protective polyurethane coating results in A. Increased takeoff distances, decreased maximum gross weight, and increased fuel consumption. B. Reduced takeoff distances, increased maximum gross weight, and reduced fuel consumption. C. Increased takeoff distances, increased maximum gross weight, and increased fuel consumption. The correct answer is A. Degradation of the parachute's protective polyurethane coating results in increased takeoff distances, decreased maximum gross weight, and increased fuel consumption. The protective polyurethane coating on a parachute is designed to provide durability and resistance to various environmental factors. It helps protect the parachute fabric from UV radiation, moisture, dirt, and other potential sources of damage. Over time, this coating can degrade due to exposure to sunlight, weather conditions, and general wear and tear. When the protective coating degrades, several negative effects can occur. Increased takeoff distances may be required because the degraded coating can create additional drag on the parachute, reducing its efficiency and lifting capabilities. The degraded coating can also make the parachute fabric more susceptible to moisture absorption, which adds weight and further reduces performance. Additionally, the degraded coating can compromise the structural integrity of the parachute fabric, leading to reduced maximum gross weight. The fabric may become weaker and less able to withstand the stresses and loads placed on it during flight. Lastly, the increased drag caused by the degraded coating can result in higher fuel consumption. The engine will need to work harder to overcome the increased drag, leading to increased fuel usage. Therefore, degradation of the parachute's protective polyurethane coating can have negative impacts on performance, resulting in increased takeoff distances, decreased maximum gross weight, and increased fuel consumption. Regular maintenance and inspection of the parachute, including monitoring and addressing any degradation of the protective coating, are important for safe and optimal operation. 7272. Flaring allows the pilot to touch down at A. Higher rate of speed and a slower rate of descent. B. Lower rate of speed and a higher rate of descent. C. Lower rate of speed and a lower rate of descent. The correct answer is C. Flaring allows the pilot to touch down at a lower rate of speed and a lower rate of descent. Flaring is a technique used during the landing phase of flight to transition from a descent to a gentle touchdown. It involves gradually reducing the rate of descent and the forward speed of the aircraft just before touchdown. By flaring, the pilot increases the pitch attitude of the aircraft, effectively raising the nose. This action increases the angle of attack and generates more lift, which helps to slow down the aircraft's forward speed. As a result, the aircraft touches down at a lower rate of speed. Simultaneously, the reduced descent rate during the flare allows for a smoother and softer touchdown. The pilot aims to level off the aircraft just above the runway surface, minimizing the vertical speed and allowing the aircraft to settle gently onto the ground. Flaring is an important technique for achieving a controlled and safe landing. It allows the pilot to touch down at a lower rate of speed and a lower rate of descent, reducing the risk of damage to the aircraft and providing a more comfortable landing experience for the occupants. 7281. Flaring during a landing? A. Decreases the powered parachute speed due to increased drag. B. Increases the powered parachute speed due to reduced drag. C. Decreases the powered parachute's drag due to increased speed. The correct answer is A. Flaring during a landing decreases the powered parachute's speed due to increased drag. Flaring is a technique used during the landing phase of flight to reduce the forward speed of the powered parachute and make a smooth touchdown. When flaring, the pilot increases the pitch attitude of the powered parachute by raising the nose. This action effectively increases the angle of attack, which generates more lift and increases the drag on the parachute. By increasing the drag, the flaring maneuver helps to slow down the powered parachute and decrease its forward speed. The increased drag acts as a braking force, allowing the parachute to descend more gradually and softly. The pilot aims to level off the powered parachute just above the ground, reducing the descent rate and allowing it to settle gently onto the landing surface. The flaring maneuver is crucial for achieving a controlled and safe landing, as it helps to reduce the speed and impact forces during touchdown. Therefore, flaring during a landing decreases the powered parachute speed due to increased drag.